Hello again. So we're at section 1.4 in our study of lines and linear functions. And in this video, we're just going to go about seeing how the slope relates to the equation of a line. In fact, what the equation of a line looks like. Well, there are several forms of the equation of a line, but the most common form is what we call slope-intercept form. And it's like this. So if x and y are our variables, and m and b are numbers, then this gives us the equation of a line. And the m represents the slope. That is, whatever is multiplied by x is the slope. And then what you're adding or subtracting this constant here, that represents b is the y-intercept. And of course, what we really mean is the point 0b would be the y-intercept. All right. So we talked. So almost every line can be described by an equation of this form. There are two exceptions. One is when m equals 0. When m equals 0, this term just goes away and we get y equals b, or y equals a constant. So we might have something like y equals 6. And we know that this describes a horizontal line. Okay, it's a horizontal line, its slope is 0, and its y-intercept will be at 6. The other case is when we have a vertical line. When we have a vertical line, the slope is undefined. So we don't really have anything like this anymore. But for a vertical line, all the points have the same x-coordinate. So for a vertical line, we just give, say, x equals some constant like -2, and that describes a horizontal line. I'm sorry, that describes a vertical line. So in this case, so the slope would be undefined because this is a vertical line, and the y-intercept in this case would be none because, well, here's our, well, your -2 would be over here, and would be like this. Okay, so there's an x-intercept, but there's no y-intercept in that case. All right, so these are kind of the two degenerate cases, all right? So let's say if we wanted to find the slope and y-intercept of these following lines. Notice all of these are in kind of a nice form. 3x minus 7, of course, this can be rewritten if you wanted to as 3x plus -7, right? So we can see that the m is 3 and the b is -7. So our slope is 3 and our y-intercept is 0, -7. All right. Here we can see that our m is going to be 5/7. That's our slope, and our b is 2. So the slope is 5/7, and the y-intercept is 0, 2. Okay. And I should say we can see without really looking at the graph that both, since the slopes are both positive, we know that these lines will be increasing. All right. Now what about this one on part C? We might have to do a little bit of work to get it in the desired form. Here we're taking x minus 3 and we're dividing everything by 5. Okay. Another way you can think about this is the same thing as multiplying by 1/5. Okay. These are the same thing. Dividing by 5 and multiplying by 1/5 is the same thing. And if we distribute, we get y. So we get y equals 1/5 x minus 3/5. Okay. So our slope, well, we can see the m will be 1/5 and b will be -3/5, right? So our slope is 1/5 and our y-intercept will be 0, -3/5. Okay. And in yet another case, we might have to do a little more work to get it in the desired form, but not only a little bit more. In this case, we have a -4 that's kind of getting in the way, so we can isolate this y by adding 4 to both sides. And so we get y equals 5x, and 10 plus 4 is 14. So m is 5, b is 14, and so our slope is 5, and our y-intercept is the point 0, 14. All right? Okay. And then once we know how to identify the slope, it's very easy to determine if two lines are parallel or perpendicular, or neither. So if we look at these cases, here we'd like to find, are these lines perpendicular, parallel, or neither? And here we can see the slope here is 6/5. The slope here is 6/5. They're the same, so they're parallel. Here the slope is 4. Here the slope is, by the way, this should be m sub 2. M sub 2 here is negative 1/5. These are neither, right? They're not equal, and they're not negative reciprocals of each other, so they're neither. Here the slope is negative 6, and here the slope is positive 1/6. Okay, they are negative reciprocals of each other, so these lines are perpendicular. And here the slope here is 7. The slope here is 1/7. They are not negative reciprocals of each other because they're both positive, right? So these are neither parallel nor perpendicular. All right. Okay. I want to go to a problem like this, number 3. Here, these are the x and y coordinates of points on a line are given below, and we'll say you want to find the remaining coordinates, and in particular, what's the slope of the line. So the way we do this is, let's first try to find the slope of the line, and we are still given 2 points here. Okay, we're given negative 3, 15, and 1/7. So that's enough to find out what the slope is. So let's first find out what the slope, and we'll go from there. So the slope will be 7 minus 15 over 1 minus negative 3. 7 minus 15 is negative 8, and this is 1 plus 3, so this is negative 8 over 4, which is negative 2. Right? All right, so this is negative 2. Now, what this means is, if our rise over run is negative 2 over 1. That means if for every 1 unit we go over 1 unit to the right, we're going to go down 2. Okay, which means that y is going to decrease by 2. When x increases by 1, y decreases by 2. Okay. Okay. So here, when we go from x goes from negative 3 to negative 2, we're going up by, x is increasing by 1, so this 15 should go down by 2, so this would be 13. Here we go, x increases by 1, this 13 goes down by 2, so that's 11. When 0, here again, x increases by 1, 11 should decrease by 2, so that would be 9. Then sure enough, here x increases by 1, 9 goes down by 2, that's 7. X goes up by 1, y goes down by 2. 7 minus 2 is 5, 5 minus 2 is 3, and 3 minus 2 is 1. Okay, so you can see all these y values go down by 2 units, right? And we can right, and we actually get a bonus here. We can see that the y-intercept is actually 9, and we'll eventually check. Well, it turns out, well, y is going to be negative 2x plus something, but we know this something has to be the y-intercept, And the y-intercept is what happens when x is 0, so it's 9. So actually, we can actually find the equation of this line without plotting it. And that will be that, and we will see you next time.